Hello everyone, welcome on this e-learning platform of Apex Institute. Here is the general information about the instructor and the course. In electrostatic chapter, electric charge is the physical quantity we are dealing. This is the second video on that. So let's proceed. In the characteristics of charge, mixed characteristics is here. The charge is frame independent. That does mean charge is independent of frame of reference. So if let's say any object, we consider this as an object, it got charge, let's say Q naught, and if somebody is watching this charge from earth and somebody is watching from moon or any platform, so platform A and the platform B will not give different answer for charge, right? That means charge will be independent of frame of reference, even though A might be moving with the velocity or whatever be that velocity. This is very special property of charge because this is not true for mass. Mass is a frame dependent quantity, so that is dependent on frame. It might seem some unusual, but that's a reality. Now we are not able to feel or visualize this kind of effects because this dependence of mass with velocity is like this. Now significant difference will be appearing only if V and C are comparable. Here V refers to velocity of frame from which you are watching this mass, and C is the speed of light, which is really very large value and the highest speed you can think of. So if V is as large as comparable to C, then you'll find this denominator will be 1 minus some significant number. So this entire denominator will reduce to lesser than 1. Then M and M naught will not be identical. Here M naught is referring to rest mass and M is the dynamic mass or a relativistic mass. So this M and M naught are not equal. That means their measurement of mass is dependent on frame of reference. So that's a frame dependent, whereas the charge is independent of frame. In all conditions you will find the same value of charge, right? The next property is quantization of charge. So charge is in the form of quantum, and that smallest charge that can freely exist is this small e, which is 1.6 into 10 raised power minus 19 coulomb. And if we need to write any charge, we can write the charge in form of this. Charge Q is plus minus ne, where n is an integer number. So that means charge on any object is integral multiple of this small packet of charge, that's called quantum. So that's what written here. It says the total charge can always be expressed as integral multiple of the minimum existing free charge, which is called quantum of charge or fundamental charge or electronic charge. So that's the least freely existing charge. However, the recent research has found out some elementary particles like proton and neutron. They are made up of some further basic particles called quarks, and these quarks are found to have a charge in fraction of E, fraction like 1 by 3, 2 by 3 of E. But we know these quarks do not exist free state, so that's why still this is the minimum freely existing charge. And the next property is conservation of charge. That means if it says the total charge within an isolated system is always constant or conserved. So if we consider any system which is isolated, whatever the charge it carries, it will remain the same charge until unless you provide from here or extract from somewhere. So that means charge cannot be created, cannot be destroyed, it can be redistributed, and for any isolated system charge remains the same. So charge is conserved. That's an important conservation law. Thank you.